Hello everyone, I am Disha, an electronics and communication student at Sri Venkateshwara College of Engineering. I am here to give a presentation on scattering matrix for E-plane T-junction. Hope my last video, which I have uploaded 3 weeks back, was informative. E-plane T. An E-plane T junction is formed by attaching a simple waveguide to the border dimension of a rectangular waveguide which already has two ports, namely port 1 and port 2, and they are called collinear ports. And there is another port called port 3, which is called as side arm or E arm. This E plane T is also called as series T. As I told in the previous slide, port 1 and port 2 are collinear arms and port 3 is the side arm. This port 3 is parallel to the electric field. So, this junction is called E-plane T junction, and this is also called as voltage or series junction. The ports 1 and 2 are 180 out of phase with each other. The cross-sectional details of E-plane T can be understood by the following figure, which I'll be showing in the next slide. The figure here shows the connection made by the side arm to the bidirectional waveguide to form the parallel port. Properties of E-plane T. The properties of E-plane T can be defined by its matrix of order 3 cross 3, and it is a square matrix. There are 3 possible inputs and 3 possible outputs, and this is my S matrix. Let it be equation 1. Scattering coefficients are S13 and S23 are out of phase by 180 degree omega. Input at port 3. As my coefficients S13 and S23 are 180 degree phase shift, so I am taking it as S23 is equal to minus of S13 and taking it as equation 2. The port is perfectly matched to the junction, then S33 would be 0. Consider it as equation 3. From the symmetric property, it states that Sij should be equal to Sji. That is, S12 should be equal to S21 and respectively. And I am considering this as equation 4. Considering equation 3 and 4, the S matrix can be written as I have substituted equation 3 and 4 in equation 1, that is S matrix, have got this new matrix. I am considering it as equation 5. From the symmetry property, I have got 4 unknowns, and by unitary property S into S conjugate, it would be identity matrix, that is 1 1 1, as the diagonal element should be 1 and other elements should be 0, so that we call it as identity matrix. As we can see here, I am multiplying S matrix with its conjugate. I am getting its identity matrix. As I am multiplying S matrix with its conjugate, considering row 1 with column 1, when S11 is multiplied to its conjugate, I can take it as S11 modulus square, and by equating this thing to 1, I can consider it as equation 6. respectively I am doing for R2, that is row 2 column 2 and row 3 column 3, and considering it as equation 7 and equation 8 respectively. And by multiplying row 3 with column 1, I am getting this equation which is equated to 1, and that equation I am considering as equation 9. Equating the equations 6 and 7, we get S11 is equals to S22, and this I am considering as equation 10. From equation 8, we get 2 into the modulus of S13 square, or I can rewrite it as S13 is equals to 1 by root 2, and considering it as equation 11. From equation 9, I am getting S13 into S11 conjugate minus S12 conjugate, or else we can rewrite it as S11 which is equal to S12 and equal to S22, and considering that equation as equation 12. Using the equations 10, 11 and 12 in the equation 6, we get S11 modulus square plus S11 modulus square plus 1 by 2, and which I am equating to 1. I have rewritten the previous equation as 2 modulus of S11 square is equals to 1 by 2. Well, I am sending this to this side. It becomes 1 by 4, and rooting 1 by 4 I am getting 1 by 2. So S11 is equals to 1 by 2, considering it as equation 13. Substituting the values from the above equations in S1 matrix, I am getting final matrix as this. You can see. We know that B is equals to SA. In the previous slide, I told that B is equals to S into A, considering B matrix as B1, B2, B3, only one column but three rows, and considering A matrix as A1, A2, A3, three rows but one column. This is the scattering matrix for E-plane T, which explains its scattering properties. Thank you for watching the video. Stay tuned for the further videos based on electronics and communication subjects. Please don't forget to like and share my video. If you didn't subscribe my channel, please do subscribe it.